the small device showing the principle of hydrogen storage of solar energy. So the idea is that, for example, we have an electric vehicle, and we want to supply it with solar energy. So of course, first we can supply directly the motor with the solar panel, like we already did. Okay, so here and here, I put the solar panel on the motor, and it doesn't work, like here. Of course it works when there is some sun. No sun, no work. So, as I told you, now we are going to store energy by means of an electrolyzer. All this is the equivalent of what I called you.
Story.
Yes, how did I call this assembly?
Accumulator.
Yes, it's just like a battery accumulator. Because this is to charge the battery electrolyzer. So you can see here, actually there is nothing happening, and now I put the light on, and you can see here the bubbles.
Yep.
Okay, the bubbles of hydrogen and oxygen. Okay? Okay? And so you can see here we are producing bubbles, and the gas is stored here.
Yes.
You know, this is tight because of the water. And so when the gas comes out from the electrolyzer, it pushes the water upside. Okay? And so the water is going up. So, for example, to verify the reaction, you will be able to measure the current so that you can calculate the number of moles of electrons produced, and then the current is converted in hydrogen and oxygen moles produced. Okay? And so here you have a graduation so that you can calculate the volume, and so you will be able to do the calculation with a relation to verify the relation between the current and the gas which is produced. Okay, so now I showed you the theoretical characteristic of the electrolyzer, and I told you it can begin to work when the voltage is over how much? So here I supply. Okay, so here it works with nearly 60 milliamps, and now I can measure the voltage across. The voltage across, so the electrolyzer here and the voltage here, and you can see it is 1.55. We saw that it is over 1.48. Okay, here it is 1.55, and maybe I can vary, you see. And here, you can see here, no current when it is less than 1.48. And then, up, it begins to conduct and to reach its working point.
Yes.
Okay, so now we are storing hydrogen and oxygen. Okay? And so now I stop hydrogen and oxygen. So I have no sun, say it's the night or it is cloudy in the sky, and I want to make my motor run. So, like when I use a battery, here I will use a fuel cell. Okay, a fuel cell, and I plug my motor on the fuel cell. This is the fuel cell. The fuel cell is supplied from oxygen and hydrogen stored in these tanks. So you know, if I don't look like that, this is like a hydrogen independent autonomous system, and of course it works. And so what you are looking here, it's a production, direct production of electricity from hydrogen and oxygen. You can see there is no other source. And you can hear no noise and only water, and you know it's very clean. And you know it works very well. Sometimes you can see here it works, but maybe we can improve the working. So what I am going to do here, you can see, I stop, and here I do what is called a purge, you know, because after a time there is water in it, there is nitrogen, so very carefully I open here, up, you see, you have seen that the gas here goes up, and the same on this side, just to push out the old gas, so that now hydrogen and oxygen has pushed nitrogen or else, and so you can see. So sometimes when it works, yes, a bit faster, yeah. So this you will study particularly with these ones. So this, you know, this is one cell, yeah. This is one cell, and here you have got several cells in series. Okay, so in the same way, of course, here, so we are going to look at it. So here, I want to measure in the same way, I want to measure the current delivered, so the current delivered in the motor, okay, and then okay, the current 36 milliamps, and then the voltage in the motor, or the voltage at the output of the fuel cell. Sorry, maybe I put, yes, I put the red one on the red one, sorry. You know, they are very small devices, but they are very interesting devices because they are realistic. You know, the big ones behaves as these small ones. So you can see here the voltage is 0.75. If I open the circuit, no, sorry, sorry. Here I open the circuit, the current is 0, and you can see a 0.9. This is a voltage open circuit of the fuel cell. So of course, when we have hydrogen and oxygen in the fuel cell, we have a voltage. The voltage is delta G on 2.5, okay? And then, of course, when I close the circuit, it delivers current, the voltage drops. So, with the motor, we have only 1 point. But with this, now, you will be able, as you did for the solar cells, you will be able to draw to the characteristic of the fuel cell. And in the same way as you did for the motor here, you can be able to draw the characteristic of the electrolyzer. So this is why we prepared with the solar how to use this to draw different characteristics. Then, of course, you can do the same to study electrolyzer, to study the fuel cell, and then you can calculate different things. We will speak about it in the next experiment.